right, so let's do some three-part questions for limits. So I just decided to get them out of the way ahead of time. So I want to take the limit as x approaches 2 of 3 over x minus 2. But what does this little notation on top mean? It means I want to take the left-hand limit of x equals 2. So as x approaches 2 from the left side of 3 over x minus 2, what strategy do I take? Well, first things first. Spoiler alert, these are the three questions to start the day. So the left-hand limit as x approaches 2, the right-hand limit as x approaches 2, and finally the limit as x approaches 2 for 3 over x minus 2. So let's just spoil it, okay? If I plug in 3 over x equals 2 minus 2, remember that I don't like it because I get 3 over 0, which means that I get a vertical asymptote. And a vertical asymptote means that it's a loop-de-loop kind of graph. There's an imaginary divider, and I want to figure out what is the intent as x gets closer and closer and closer to 2. Do they go to infinity? Do they both go to negative infinity? Or does the limit just not exist? So let's take this piece by piece. So if I plug in the left-hand limit as x approaches 2, think to yourself 1.9999999. So I'm going to do that. I'm going to go with 3 over the left-hand limit of 2. Sorry, the left side of 2 minus 2. So if I do 1.9999999 minus 2, that's going to be barely negative. So that's going to be 0, but we're approaching 0 from the left side. So 3 over 0, right, I'm just going to clear that up. There's a theory in calculus that says 3 divided by 0. Even though it's algebraically impossible, 3 divided by 0 is infinity. But if this is positive divided by negative, that has to be negative. So the left side of the left-hand limit as x approaches 2 is y wanting to go to negative infinity. Okay, so let's take a look at the right side now. The limit as x approaches 2 from the right-hand limit for 3 over x minus 2. So what do I mean by the right-hand limit? Well, that is a little bit bigger than 2. So what's a number that's just barely, and I mean barely bigger than 2? Let's think to ourselves 2.001. So if I just go barely to the right of 2, that's going to be 3 over 2.001 minus 2, or if you want to use proper calculus notation, you say the right-hand side of 2. So if I have 2.001 minus 2, that'd be like positive 0.001. But remember, it's so close to 0, it's practically 0 from the right side. So then, let's just cover the basics. Positive divided by positive, well, that's going to be positive. And then 3 divided by 0 from the right side is positive infinity. So if I look at my left-hand limit and my right-hand limit, as x gets closer and closer to 2, the left side wants to go to negative infinity, the right side wants to go to positive infinity. Therefore, the limit as x approaches 2 for 3 over x minus 2 does not exist. Okay? So that literally is an answer. The limit does not exist. Okay? Turn the page. Figure out whether the limit as x approaches negative 5 for 3x over 2x plus 10 exists or not. So I'm a thought bubble kind of guy. I have thoughts. 3 times negative 5 over 2 times negative 5 plus 10. Well, that's going to give me negative 15 over negative 10 plus 10, or negative 15 over 0. Hang on, let me make that a little bit darker. Come on, pen. There we go, pen. Either way, negative 15 over 0, I'm terrified. I'm scared, because that creates a vertical asymptote. Okay? But now I need to figure out, do they both go to infinity? Do they both go to negative infinity? Or does one go to infinity, the other go to negative infinity? But either way, do they just not agree? Let's find out. So if I'm plugging in the left-hand limit, I'm thinking to myself, what's barely underneath negative 5? So what's a number that's barely smaller than negative 5? Think to yourself, negative 5.001. So if I plug in 3, and I'm doing this for both, and over here, well, 3 times negative 5 from the left side, that's not going to get me, any different from, a negative number. Because even if I did negative 5.01 or negative 4.9999, I'm still going to get about negative 15. Okay? But this is where it gets a little bit complicated. So if I've got 2 times negative 5, and that's going to be, plus 10 over here. 2 times negative 5 is negative 10. But remember, if I had negative 5.001, 2 times negative 5.001 would be around negative 10.0, so on and so forth. So it is technically the left side of negative 10. So something that's a little bit stronger than positive 10 makes this negative 15 over 0 from the left side. And yes, this is actual calculus notation. So first things first, I've got a negative divided by a negative. So that makes it a positive. And 15 over 0 is positive infinity. So the left-hand limit goes to positive infinity. Now let's plug in the limit as x approaches negative 5 from the right-hand limit. So now let's plug in positive. Oh, I don't want to confuse you. So I'm going to plug in negative 5 from the right side. So 3 times negative 5 from the right side over 2 times negative 5 from the right side plus 10. Well, 3 times negative 5 is just going to be negative 15. If I go from the right side, it's still going to be like what? Negative 4.999999 times 3. So it'd be like negative 14.999999. Either way, negative 2 times negative 5 is going to be negative 10. And that's going to be a plus 10 over here. But remember, if I'm thinking to myself negative 4.999999, so then negative 4.999999 times 2 would be like about negative 9.99999. So this would be the positive side of negative 10. Yes, this is proper calculus notation. I'm not making this up. So this is negative 15 over, if we've got negative 9.99999 plus 10, that'll be 0 from the right side. Now, let's get this part out of the way. A negative divided by a positive is technically a negative, and 15 divided by 0 would be infinity. Therefore, the limit as x approaches negative 5 from the right-hand limit would be negative infinity. So now I compare the left-hand limit and the right-hand limit. They don't agree on where they both want to go, so therefore the limit as x approaches negative 5 for 3x over 2x plus 10 does not exist. Okay, let's say I do one more of this. So let's say I've got the limit as x approaches 3 for 9 over x minus 3 squared, and I want to figure out whether it exists or not. So I'm going to plug it in. And remember, if I plug in 9 over 3 minus 3 squared, that's 9 over 0 squared or 9 over 0, I'm not happy. I've got a vertical asymptote. So let's figure out where they agree or whether they agree or disagree. So I want to take the left-hand limit. So think to yourself, just barely under 3, 2.9999999. So I'm going to plug in 9 over x minus 3 squared. So if I'm thinking just barely under 3, 2.9999999, that's the left-hand side of 3. So therefore, if I've got the left side of 3, so 2.9999999 minus 3, that's going to be like negative 0.0001. So that's 0 from the left side, but remember that's going to get squared. Now, what's a negative quantity squared? A positive. So I know what you're thinking. It's like, okay, 0 times 0 is 0, but the difference is we're approaching it from the left side. So negative, so if this was negative 0.001 quantity squared, well, that's still going to be really, really close to 0, but a negative times a negative will be a positive 0.00001. So it's the positive side of 0 now. Now, let's take a look at this problem. A positive divided by a positive is a positive, so 9 over 0 is infinity. Therefore, the left-hand limit as x approaches 3 is positive infinity. Well, let's check this part out over here. So if I'm plugging in the right-hand limit of 3, I'm approaching x equals 3 just barely bigger than 3 from the right side. So think x is equal to 3.001, but we're really just getting arbitrarily closer and closer to 3. So let's do that. So I'm going to plug in 3 from the right side and use direct substitution and a little bit of creativity, because calculus, some of you guys looked at this like, what is going on here? And some of you guys are like, this is the coolest thing ever. And when I was in college, I was like, I have no idea what you're talking about, man. But I've learned to appreciate it. So if I approach this as 3.01 minus 3, I'm going to get barely positive. So 0 from the right side. And that's going to be squared. So 9 is still on top. If this was 0.001 getting squared, a positive times another positive is just positive. So it's just going to get really, really, really small, but still positive. So 0 from the right side. 9 over 0, positive divided by positive, is still positive. So 9 over 0 is infinity. So the left-hand limit as x approaches 3 is infinity. The right-hand limit as x approaches 3 is also infinity. So the limit as x approaches 3 of 9 over the quantity of x minus 3 quantity squared is positive infinity, even though there is no point as x gets closer and closer to 3. They both agree that we're going to the sky. We're both going to infinity. Okay? So I just want to bring up, why did I go over this again, even though I did this on the previous video? Is because I want to bring some helpful hints. So the big clue to understand is if you have an odd exponent. So let's say you've got, let me just get these out of the way. For the fifth power. Okay. So if there's no exponent, it's automatically to the first power. That is still barely negative. And this is barely positive. Okay? Odd number of negatives, negatives times negative times negative is still barely negative. So that's still 0 from the left side. Negative times negative times negative times negative times negative is still from the left side. And odd exponents, if I've got 3 positives, I still get 0 from the right side, and so on and so forth. But if the exponent is even, so if I've got 0 from the left side getting squared and 0 from the right side getting squared, or 0 from the left side getting to the 4th power, or 0, and so on and so forth. So the big hint that I want to tell you is we just use everything in algebra at our disposal. It's like the ultimate endurance round, but with so close to 0. Isn't that awesome? So if I square a positive, I still get 0 from the right side. And if I square a negative times a negative is a positive, but if I'm multiplying by a number so close to 0, and I square it, I get even closer to 0. So it's technically 0 from the right side. Okay? So the point is, if I'm so close to 0, I'm practically 0, pay attention to the parentheses, pay attention to the exponent. That is my biggest hint for limits that involve infinity. Have a great day. I'll do a video for Thursday just to get you psyched for the next unit. There's no test. Okay? We'll have a test when we come back from spring break.